Hey guys, Mrs. Shelton coming to you from the Move Up Academy today. You will not believe what I did. I actually recorded this whole video once. It took 8 minutes. And when I went to download it, there was no volume there. So this is round 2 for me. I hope that I get a little bit better. I apologize if you hear any sniffles during the video. It seems as if I'm catching a cold. And I sometimes have to pause and take a drink of water. So let's get started. Yesterday, you completed the lab portion of activity 24, diluting the problem. Today, there are 3 essential things that I want you to do. And the first begins with calculating the concentration for each of the solutions found in cups 1 through 9 of your CPUP tray. That being said, let's take a look at the transparency that you started with yesterday. Okay, we know that in cup number 1, you put 10 drops of 100,000 parts per million copper chloride. From that 1 cup, you then took 1 drop of the solution and placed it into cup 2 and added 9 drops of water. You then took a drop from cup 1 and put it into cup 2, adding 9 additional drops of water. Okay, our goal today in this portion of the activity is to figure out how much copper was actually present in the solution. And that's my goal today, is to help you get to where you can determine that. I think that it should be quite obvious, simply from looking at this, that the concentration in cup 1 was 100,000 parts per million, as it was shown on the bottle. Okay, please remember that 100,000 parts per million is equivalent to the fraction 100,000 per million. So let's take a look at this data. Okay, I believe that when you finished, your results should have looked similar to what you see on this slide. Okay, and in cup number 1, you should have found a mint green colored solution. As I mentioned, this particular substance that was in cup 1 was 100,000 parts per million. In other words, 100,000, okay, over 1 million. So if you then look at student sheet 24.1, you are going to be determining the concentration of this substance. We know that the parts per million in cup 1 were 100,000. That information was given to us. If we are to then write this as a fraction, okay, we would record this as 100,000 per million. Please go ahead and record this information on student sheet 24.1. The next step then, after you have written this as a fraction, is to show how the fraction can be reduced or simplified. Okay, to do this, we're going to cross off the same number of zeros in the denominator as the numerator. If we were to do that, this 0 is gone, and this 0 is gone, and this one, 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 which would leave our simplified fraction then, whoops, I'm having a hard time clicking there, as 1 over 10, or 1/10. And doesn't that make sense, guys, as you start to think about each of the cups in our CPUP tray, that each of them is 1/10 of the previous cup. So let's go ahead and let's continue on. And let's determine and solve the concentration for cup number 2. Remember that in cup number 2, what you did is you took 1 drop from cup number 1 and placed it into cup number 2 and then added 9 drops of water. To determine the concentration for this cup, what you are going to need to do is to jot down the parts per million. Okay, remember that each cup was diluted with 9 drops or parts water to 1 drop or part solution. This means that each cup was 1/10 as concentrated as the cup before. So to determine the concentration in cup 2, the denominator is increased by a factor of 10. We will do this by multiplying the denominator 10, which is the concentration in cup 1. Okay, here's 10. We're multiplying that by the concentration in cup 1 by 10. Okay, in other words, the concentration in cup 2 is 1/100th of that in cup number 1. Okay, another way of saying this is if we were to take the 100,000 parts and we are going to reduce that by 1/10, we would end up with 10,000 parts per million. To write this as a fraction, we take our 10,000 parts per, remember, per is our fraction bar, 10,000 parts per million. Okay, again, if we work this backwards and we reduce, okay, the 0 with this 0 and this 0 with this 0, we would end up with the simplified fraction of 1/100th. In other words, the concentration in cup 2 is 1/100th of the original concentration. Okay, we could continue on. And when we look at cup 3, we found that cup 3 was a lighter blue. Okay, and that is 1/10 of the concentration found in cup number 2, or 1,000 parts per million. To write this as a fraction, we simply take our 1,000 parts, remember, per is our fraction bar, million. Okay, again, if we want to simplify this, all we do is cross out our zeros in our numerator and denominator, and we will find that this is 1/1000th, okay, would be our simplified fraction. I'm going to ask that you continue on in order to determine the concentration for cups 4 through 9. When you are finished with that, please continue on to your analysis questions. You are responsible for analysis questions 1 through 6, as well as your scoring guide. If you finish all of that, please note that you do have academic vocabulary for activity 24 that you can add as well. I hope that you guys have a great day. Please be great students for Mrs. Robinson. I know she will greatly appreciate it, and I look forward to seeing you tomorrow.